cubic inches that you can fill, and each conductor and device takes up so many cubic inches of that box. Now, let's do some practice questions and get to it. What size round octagonal box would you select for 9 number 12 conductors? For this one, we're going to be using Table 314.16a. We're going to start here and we're going to find our gauge of wire. Then we're going to come down and we're going to find a box, making sure to cross over and double check that we don't crest over into a different style box. We want to stay in the round octagonal. We find our conductors, we find the one that fits it, we slide over and double check ourselves, and we're going to select A. Great job! What size round octagonal box would you select for 7 14 gauge conductors? We're going to head to Table 314.16a. We're going to start here on the right-hand side and we're going to find our gauge wire. Then we're going to come down and find a box that fits it and be sure when we cross over that we stay in the right category of box, and we're going to select C. What size 4 square box would you select for 8 number 8 conductors? We head to 314.16a. We're going to start here on the right-hand side and we're going to find our size wire. Then we come down and make sure that we're in the right type of box. We cross over and we're going to find that it's A. How many number 10 conductors can you fit inside of a 4 11/16 by 1.5 inch square box? It's the same process, just looking at it differently. We're going to go ahead and come to our table, 314.16a. We're going to find our gauge conductor. We're going to come down and find our box. Make sure we cross back over, and we find that we can fit 11 inside of this box. How many number 8 conductors can you fit inside of a 4 by 2 1/8 by 1.5 inch device box? We head to 314.16a. We're going to find our gauge wire. Then we're going to come over and find our type of box and size, make sure we do everything correctly, and we're going to find that it holds 3. What is the maximum cubic inch volume for a 3 3/4 by 2 by 2.5 masonry box? For this one, we're going to head to 314.16a, and we're going to use that middle column, that volume column, and we want to find out how many we can do. We come down, we look very closely, and we find that it's 14 cubic inches. This is very important that we understand this process before we move on into more complex box fill calculations. What is the maximum cubic inch volume for a 4 11/16 by 1.5 inch square box? We're going to use the same process. We head to our table. We're going to go to that volume column, and we're going to come down and find our correct type of box. And we're going to find that it's 29.5 cubic inches available area to fill. How many more number 10 conductors can you fit inside of a 4 11/16 by 1.5 inch square box that already contains 6 number 10 conductors in it? Well, since both of these are of the same size, we can just do some simple math. First, we have to find out how many the box holds at all. And we go in and we find that it holds 11. Then we have to do some simple math. We already have 6 conductors, so we take our original 11 minus 6, and it lets us know that we can put 5 more inside of that box, and we select A. How many more number 12 conductors can you fit inside of a 4 by 2 1/8 by 2 1/8 device box that already contains 5 number 12 conductors? For this one, we're going to head back to our table 314.16a. First, let's find out how many wires it can hold originally. It can hold 6. We already have 5, so we take 6 minus 5 equals 1, and we can put 1 more conductor inside of this box. What is the cubic inch volume for a number 6 conductor? For this one, we're going to head to 314.16b. We're going to start here on the left-hand side of the table and find our size conductor. Then we're going to come over and we're going to cross over to our cubic inch volume, and we're going to select D. Great job! What is the cubic inch volume for a number 12 conductor? Head back to 314.16b, start on the left-hand side and find our size conductor, then cross over to the cubic inch volume, and it's stating that for every number 12 that's in that box, according to the count, which we're getting ready to learn, takes up 2.25 cubic inches of that box. Let's get to it. What is the total cubic inch volume you would calculate for 4 12-gauge conductors and 3 14-gauge conductors? First thing we're going to do is head to our table. Now we have to do some simple math. Let's grab all of our 12 gauge conductors first. We have 4 of them. Multiply it by 2.25. That equals 9 cubic inches. Now let's snag our 14s. We take 3 multiplied by 2, and that gives us 6 cubic inches. But now we can't forget to add them back together. Total it all up, and these conductors are taking up 15 cubic inches of this box, and we're going to select C. What is the total cubic inch volume for 3 10-gauge conductors and 5 8-gauge conductors? We head straight to our table. We do some math here. We bear out the 10-gauge conductors. Then we bear out the 8-gauge conductors. We total those two back together, and we find that it's taking up 22.5 cubic inches, and we select B. What is the smallest device box you could use to fit 4 12-gauge conductors and 3 14-gauge conductors? For this one, we're going to be using tables A and B. Let's start over here in table B and get our total count. Then we'll go to table A and find which box fits it. We do the math on our 12-gauge conductors. We do the math on our 14-gauge conductors. These conductors are taking up 15 cubic inches. The code wants to know the smallest box that will fit it. So we come over here to our middle column, the volume column, and we slide down until we find a device box that just fits it. And we're going to find that it's a 3 by 2 by 3.5. What is the smallest round octagonal box you could use to fit 3 10-gauge conductors and 3 12-gauge conductors? For this one, we're going to be using both the tables again. Let's go ahead and bear all of our math out. And we find out that these conductors are taking up a total of 14.25. Now let's head over here to table A and go down the volume column until we find the right type of box, which is right up here at the top. The round octagonal boxes. Find the one that fits, and it's a 4 by 1.5 inches. Great job. Now let's learn about the rules for box fill. We're getting ready to cover a lot of ground, and this is something that you have to master. But don't feel like that you have to master it in one pass. Watch this part of the video over and over until you thoroughly understand it. We're going to learn how to count conductors now for our box fill calculations. We have to accommodate for each wire and then also for the different devices and fittings that we use out in the field. We're not going to be dealing with equipment grounding conductors at first. We're going to calculate those separately at the end of this slide. So now we're dealing with only neutrals and hots. Each conductor counts as 1 of whatever gauge it is. So each 12 counts as 1. Each 10 counts as 1, whatever gauge wire it is. Each conductor that passes through the box counts as 1. So even if it doesn't terminate or splice inside that box, if it's passing through that box, it counts as 1 each. Each internal clamp only counts as 1 total based off the largest conductor that's in the box. Let me show you what I mean. This is an internal clamp. The clamping mechanism is inside the box. Well, it's taking up some of my space, so we have to account for it somehow. What this code is stating is it doesn't matter if I have 1 or 5 of these clamps, we're only going to count it as 1, and it's going to be grouped with whatever the largest conductor is in the box. Meaning if I have 12 and 10 gauge conductors inside that box, this internal clamp would count as 1 10 gauge conductor. All of the fittings we're going to convert over to conductors, then the conductors we're going to convert over to the cubic inches, and you'll know more of what that means as we go through this lesson. This is an external clamp because the clamping mechanism is on the outside of the box, and we don't have to count those at all for box fill purposes. Next, each stud or hickey that is present in the box shall count as 1 total based off the largest conductor that's in the box. Now, these are really old words, probably from the 30s if I had to imagine, but they still use them on examinations today. And this is what we're talking about. Imagine that we're hanging a chandelier. This we would call the stud or the nipple. Or, this would be the nipple, this would be a nipple. But they're calling this the stud and this a hickey. And they still use this terminology on exams today, so you definitely need to understand. In this scenario here, in this picture, the stud would count as 1 of whatever gauge was in the box that was the largest, and the hickey would count as 1 of whatever gauge was in the box that is the largest. And we're going to do lots of practice, so don't worry about it. Now we need to account for device straps and yokes. What the code states is that for each device strap or yoke, it's going to be counted as 2 based off the largest conductor that's connected to the device. As we learned earlier in the program, this is a device yoke, or what we call a device strap. So each one of those, and how I like to think about it, is each gang of a box. If you have a single gang box, 2 gang box, or 3 gang box, each gang is going to count as 2 based off the largest wire that is connected to the device. So if I had a box that had 12 gauge on one switch and 14 gauge on another switch, the first switch would count as 2 12s and the second switch would count as 2 14s. Now let's deal with equipment grounding conductors. Let's deal with the 2017 first. If you are on the 2017 code, this is how you deal with equipment grounding conductors that are in the box. It's only counted as 1 total based off the largest conductor in the box. Meaning it doesn't matter if you have 10 equipment grounding conductors, they all only count as 1 for your count total, and it's based off the largest conductor that's in the box. So if I have 10s and 12s, it's only going to count as one number 10. Now in the 2020 and in the 2023, it's a little bit different. Up to the first 4 conductors, it's going to count as 1. Then for every one that is past 4, you're going to increase it by a 1/4 inch volume. And we're going to do some practice questions with these. Just let that soak in, and when we get to the practice questions, we're going to expound on it more. If you're still on the 2017, when I come to this part of the lesson today, I want you to just fast forward through it. You don't need to learn it. It will just confuse you. 2017 will come first, and the questions will state what year I'm dealing with. Then when we get to the 2020 and the 2023, I'll let you know, and that way you can learn your respective lesson. Let's get to it. What is the total cubic inch volume you would calculate for a light box that contains 3 12-gauge conductors with 1 stud and 1 hickey present in the box? For this one, we're going to go to table 314.16b. We know that each 12 is 2.25 cubic inches. Now let's count our conductors. We know that we have the 3 number 12s originally, but now we have to deal with the studs and the hickeys. Our code states that for each stud and each hickey, they count as 1 each based off the largest conductor that's in the box. In this case, we only have number 12s, so they're going to be grouped with the 12s. So that lets us know that we have a total of 5 number 12s. That's what I meant by we're converting everything back to conductors, and then we can do our multiplication. We take those 5 number 12s, multiply it by the cubic inch volume for 12, and we end up with 11.25 cubic inches, and we would select C. What is the total cubic inch volume you would calculate for a light box that contains 3 number 12 gauge conductors, 3 14 gauge conductors, and 1 hickey present in the box? We'll head to our table. We know that each 12 is 2.25. So you always deal with the largest conductors first. And the reason is because your fittings are likely going to be grouped with the largest conductors. We know that we have the 3 number 12s, but now we got to deal with our fittings. In this case, we have 1 hickey. Each hickey counts as 1 based off the largest conductor that's in the box. And what we're going to do is group it with the 12s. We have the 3 original conductors, the 1 fitting. We have 4 number 12s. We bear that math out and end up with 9 cubic inches. Now let's deal with our leftover conductors. We have 3 14 gauges. We take and bear all that math out. Then we total it together and we end up with 15 cubic inches that all of this is taking up in this box. This is something that you'll have to take your time and master. One of my favorite sayings is, you don't wake up on that level. You don't wake up understanding this. You don't watch the video once and get it. If it were that simple, anybody can do it. I hope it's been very easy for you to understand up into this point, but for you to truly master it, you got to get after it. What is the total cubic inch volume you would calculate for a box that contains 8 number 12 gauge conductors and 2 single pole switches in a 2-gang box? We look at 314.16b. We know that each number 12 is 2.25. Let's go ahead and count our conductors. Each device yoke counts as 2 based off of whatever wire is terminating to the device. We know we have 8 original conductors, and we only have one size wire, so we know it's going to get grouped with the 12s. And each one of those devices counts as 2, so we end up with 4 more number 12s, which gives us 12 12-gauge conductors. Now we take and do our math, we end up with 27